Welcome everybody. My name is Tom Breza. I'm one of the hosts for C++ London. So let me introduce our teacher. Today is Oliver. He's another teachers and organizers. We're missing one extra person, which will join us hopefully shortly. He is as well our teacher. So, what we're going to talk today. First of all, we would like to say thank you to these guys. Yes, Binary District and Primal Base. They came to rescue and they allow us to use their site, which is massive. Thank you very much. So, anybody who is on the Twitter and so on, do tweet, let them know that we have a good friends. We would like to say a massive thank you as well to these people. The reason being they decided to help us out and make a regular contribution to our group. Thanks to them, we can buy mics, another gizmo that helps us to make this presentation better, and they will be much more useful later on when somebody is browsing the YouTube channel. So massive thank you very much to these guys. We still, I know it's a boring subject, but we're still looking for a house. So if we want to have like a very regular classes, as you saw last couple of times, we had to cancel last moment because we didn't secure a space. So in order to not to have such a nasty surprises, I need some help from you as well. Yes, I'm asking everywhere, but it's a free event, so if you can help, that would be really appreciated. So where are we? Basically, we are now. I should update that actually. We are under test-driven development. We are on a week 3, and after that will be introduction to templates. And after that, depending if any slots missed, any classes missed, we are starting a new course. The thing is, we are starting a new course on the 10th of September, if I'm memory serves well. So if the worst case is worse, we might have to skip the templates. Yeah, so that's the reason it's so important, because we start advertising that the new course, the Hello World, is starting at the beginning of September. So obviously we can't then tell people, okay, we will disappear and come back in a couple of weeks' times. So unfortunately, if we don't find spaces in between, then maybe the introduction to templates will be abandoned. So how do we work? We meet twice a week, Tuesdays. So what you're experiencing today, it's a lecture. So Oliver will explain a subject. In this case, it's a part 3 of our TDD and BDD, so test-driven development and behavior-driven development. After that, on Thursday, there's a way less formal meeting. You have to RSVP for that event, so mostly Oliver will join you in less formal place, like coffee shop and so on. We'll sit down and work on what you learned today, or on some sort of project which are helping you to get better at C++. So don't skip the Thursdays, because they're really brilliant. It's like getting one-on-one almost with experienced developer for free. Well, cost of coffee. If anyone needs license, please do contact me. You can contact me on the Slack or send me an email. The best way to get a license, I will redirect you to send an email so I can reply to you with the license, and you will get a 6 months license as a good stuff from JetBrains. They're really good friends of ours, and they said they don't mind for our course to give their commercial product for free to students.
And that would be licenses with an N normally. You broke it again.
What do you mean?
You misspelled licenses again. It's not how you spell licenses.
You see? Nobody noticed.
I fixed it once.
Yeah, because it's an old template. It's an old template. Sorry about that. Nobody noticed anyway, except Okay. Obviously, a bit of plug. How would you like to support us? Yes, if you do, yes, at least three ways. The most sought after is sponsors in the middle. Yeah, so some bigger business who would like to be in us, a great folks. They can help us with the space, pay us some money so we can the space or do something nice. Patreon, this is something which you feel if you like it, if you benefit, only if you work and if you're fully employed with their full wages and so on, you're very welcome. And finally, socialize, yes? So when we go after the class to pub, make sure this guy and Tristan, the experienced developers who really passing their knowledge for free to you, yes, they look after. So buy them a beer, buy them a hot meal, so go back home fed and satisfied. Because as you can imagine, to prepare a class for like that, this guy he needs approximately a couple of hours. Then the class for 2 hours and so on. It's pretty much half a day. Half a day of well-paid developer commands quite a lot. So let's make sure they're happy and come back. You can as well, if you can't do any financial support, spread the news about us. Anyway, talk to friends, your boss, your colleagues, and so on. The more people know about us, the more we can help other people. And always check our website. I try to put all the information on what's going on our website. So today, for example, yes, I put that today event is happening here, and I got a message some people turn up at Mimecast. So some people don't read the website, yeah. So do read the website, and then you'll get the best from the group. So that's all from me. I'm passing now you in the good hands of Oliver.
All right. Hopefully we've switched over. Yeah, that's picking me up beautifully. Excellent. Okay. So let's end this and kick this off. All right. So first thing I'm just going to say is that I'm currently ill, sadly, today, and I'm suffering with a very sore throat. Well, you wouldn't know it right now, so I'm relying on copious quantities of various drinks to sort of try and allay it. So far, my greatest success has been with beer, and it's the evening, so beer it is. Right, so on with test-driven development. As usual, the feedback side. We do love to hear from you. We especially love to hear from you when you're not sure where you're supposed to go as well. We are in the same building as Mimecast at the moment, but we are not at Mimecast. We're on the 32nd floor. So if you are confused, you could have joined our Slack. You could get it on your phone. There's an app for it. I was monitoring it. You could have asked. I would have told you where to go. So if you're not on Slack, just get on there in case you get lost and can't find us. But also feedback, of course. Naturally. So we'll have a quick recap of the previous lesson. Obviously, we covered mocking. This is where I've now completely forgotten to insert animations in certain places, so it's all in front of you. But anyway, we covered mocking. What is mocking? I.e., you have an interface, you have a real implementation. Sorry, one sec. Here's my voice going again. You have a real implementation. You have the interface that implementation is actually fulfilling. And then because you have an interface, you can have what is called the mock implementation, right? It's not the real one. It's a mock of it, a mockery, right? We discussed when it was appropriate to use this functionality. So we were specifically talking about when it makes sense to actually mock a class. So in the case of the design we spoke about, the blockbuster thing, sometimes you may have small concrete classes that are used by a larger one, and they're only used in one place. And if that's the case, then there is probably no point in mocking it. If, however, it's going to be a class that's used by multiple other classes, or there could be multiple implementations, then you would expect to have a mock via the interface. So that the classes that will use the real one don't have to be plumbed into the real one in order for you to test it. You can create a fake one that will verify inputs, give back your desired or contrived outputs, and they're tested in isolation. We discussed Trompe-l'oeil. Sorry for Lauren. Trompe-l'oeil, which is a mocking framework. So it gives you all of the lovely convenience that you need in order to test your code in a convenient way. Because, of course, you could do mocking completely by hand, but it's probably not going to work very well. And if we're going to use like the TDD framework, such as Catch, which we are, then Trompe-l'oeil integrates very nicely into this. And then, of course, as I've been mentioning already, there's interfaces. They are, of course, this is the core component that enables you to mock your classes. So, since it has been 2 weeks, I think it's probably good to just revisit some of the essentials. And also, this may partly be because I've just been fairly ill, not feeling it, and been copy-pasting slides. But I think it's always good to do revision. I have new things to say, I'm sure, subconsciously at least. So here we go. Sorry, one more quick drink. Okay. So first of all, maybe this is obvious. I'm sure it is obvious, really. The concept of TDD applies universally. You can leverage this in any programming language. We're teaching it to you in C++, yes, of course. But there's a lot of value in this course purely in terms of applying TDD to your coding, applying that style of coding. You write in code that's going to test other code. And that's extremely powerful because you, one, have this separation now. You have your implementation as you would do back in the day, but you now have this entire body of other code that is responsible for testing that implementation code. And it prevents rot, right? Somebody wants to come along, they want to make a change, fine. They have to write a test first. Or if for some reason they don't write a test first, assuming you've robustly written your tests, if they do change the implementation, they will break a test. And they will have to fix that test in order to make it pass. If they ever delete the test, find them and shoot them. And obviously this makes you change your thinking as well. It affects the way you think about how you're going to design your code. You need your code to be testable, which means that you will need to expose certain pieces of functionality in that implementation. So it will directly impact how you design your class hierarchies. It will directly impact how you write interfaces. If you're doing true TDD, you will never write more code than you need, or at least you think you need, because you will be forced to write a test. And as much as I love writing tests and writing reliable code, it's very satisfying to do TDD. And after a week or however long it takes to build it of hacking away and having it work first time is really satisfying. But nonetheless, I don't want to have to write more tests than I need because that's time consuming. But if I can't write more tests if I don't want to write more tests than I need, I must not write more code than I need. I can't just go, oh, well, maybe I want this function in future. Well, that's fine, maybe I will. But now it's my responsibility to write a test for it. And then I sort of think, well, I'll do that when I actually need it. So it reduces the amount of code that you end up writing because you are following the strict rule that you write a test first, and then you go and write the code to pass the test. And because you have to write a test, you probably won't want to write more than you need. So, of course, speaking of TDD, the overall process is very simple, right? And again, this is applicable to any programming language. You have red, right? The red traffic light. You create a test first, which is failing. Failing means it's not compiling, or it is compiling, but it runs and the test framework says this didn't pass, you didn't meet an expectation, or it runs and just crashes horribly. All of these various things are a failure. And you want a failure first. You need to verify that the test actually fails before you start implementing. So you know that you don't, by some weird coincidence, have a test that's passing. Because if your test is wrong, because again, the test itself is code, right? If you make a mistake writing the test, you could make a mistake that results in the test passing. So we expect it to fail first. That's a good safety check to ensure that our test is most likely correct. It's not a guarantee, but it gives us some assurance. And then we want to go green, right? We write the bare minimum of code to make that test pass. And as I've said in the past 2 lessons, there's varying degrees of bare minimum. Maybe a function should return 5 if I pass it 2 and 3, right? It's a function that adds 2 numbers together, so I pass it 2 as the first argument, 3 as the second argument, needs to return 5. Well, obviously the real solution is you just do, first argument plus second argument, right? Return that. But you could just do return 5. it passes the test, right? But then that's useless, really. It's not doing what you want it to do. But you know that. You know what you've done. You have to now write a second test, right? You'll write a separate test that passes 4 plus 4. And now that second test is going to pass. The old one's still going to fail. So the new test will fail. The old one will still pass. And then you're forced to generalize, right? You'll say, OK, now I actually need to make it do A plus B. And then the old test should pass. And the new test should also start passing. And then refactor, right? Not really a traffic light, but it's the so-called third stage. You're reorganizing your code. You're cleaning it up, right? When you want to make it pass, you just write what you need to make it pass. It might not be very pretty, but once you've made it pass, you know the correct solution. You can maybe, commit that correct code, and then just start cleaning it up. And if you make any mistakes while you're cleaning it up, you'll break a test. Right? When you refactor, you're not changing any behavior. You're just reorganizing the furniture. You're making the code a bit more pretty, right? Restructuring it, but not actually changing its behavior. And again, as I've been saying, if you think of some new cases to handle, then go ahead and write more tests. So in terms of writing test code, it could just be some functions in a separate executable with its own main. You'd use some implementation code, that you want to test, your actual functional code, and then you just check that it gave you back what you wanted, and you could, not return 0 if it's failed, right? And otherwise return 0, so you can just check it on the command line if it was 0 or not. But that's not very useful, is it? Because if it does fail, well, you know it's failed, but you don't know where it's failed. You don't know why it's failed. So we can obviously do better, right? There's a lot of languages that have these, various frameworks for making TDD, making testing better, a better experience, and also making it much easier. And in C++, for those of you who've already seen these slides, of course, there's no exception. There's catch, there's Google test, and there's boost test. And we're going to focus, I know any more, and we're going to focus on catch today. So now I'm just going to revisit mocking. Who was here for the mocking session? Who feels that they remember most of it? Okay. All right. Well, I might pick your brains for a few bits. So, first of all, what is mocking? Actually, that's the first one. Who thinks they can answer the question, what is mocking? Just a terse, basic.
So it's testing the interface. Test.
One more time.
Testing the interface.
Testing the interface, yeah. I was going to repeat. Yes. You have some interface. Well, that's one method of testing. The interface. So I'm not focusing so much on the way of mocking. So there's various techniques for mocking, right? Using interfaces as a technique. But yes, basically you nailed it. Mocking is typically an implementation of an interface that is pretending to be the real thing, right? It satisfies all of the requirements of that interface, but each individual unit test is going to configure that mock to expect certain inputs and return certain outputs. And this is when we need to obviously artificially control behavior. So, the real class, if you give it 2 and 2, will return 4, right? Because that class is just adding numbers and it's correct. But maybe in our other class that's going to use that, it needs to be capable of handling things going crazy. So if we give 2 and 2, the mock will actually return 5. And then the class that's going to receive that will need to be able to cope with getting that effectively garbage output. This is obviously an example. You get the idea. It's, as I've said, simulating something going wrong, or simulating a particular result, or perhaps a particular result that's considered something going wrong. And this is obviously great because it allows us to segregate the individual concerns, right? You have a class that's responsible for, in this particular case, addition. You might have another class that's responsible for storing a series of numbers in order to add them all together. And they don't know about each other, right? They're both interfaced away from each other. So we can test them in isolation, but then sort of plumb those interfaces into each other. You know, it's like your car, right? Your car has a standard interface for its wheel. It takes a tyre. It doesn't matter if the tyre is made by Goodyear or Dunlop, right? The interface is that it must be made of some material, have specific dimensions, you know, usually rubber, obviously. Made of rubber, has specific dimensions, and as long as the tyre satisfies those conditions, it will fit on the wheel of your car, and you can drive with it. And this is basically the same principle here with code, right? We define a set of functions in a class usually. Those functions have a name. Those functions take some inputs, or maybe none. And those functions return something, or maybe they don't. Depends on what they do, what you've declared them to do. So what can we actually test with mocking, right? I mean, we've got a fairly good idea, but you know, it's allowing us to ensure our code is correctly interacting with some kind of abstract interface that doesn't do anything, but is describing what implementations will do. And as part of having a mock function, a mock class instance, that mock can verify for us if a function is called or not called. We can say that we expect something to be called or we expect something not to be called. We can use it to provide some data to the code. So the code calls a function. The function then returns a contrived value via the unit test. We can have it expect some data, right? It needs to pass us, you know, the string hello and world. And we will verify that it did in fact pass those strings and that those are correct. So our test can also verify that the input to our mock from the implementation code is correct. We can also use it to throw exceptions, right? So the actual real code, that we're going to use, that we're writing, gets tested, it calls the mock, and then the mock throws an exception. And we do this because we want to see, or want to ensure, that our implementation code can handle that exception. So in the event of something going horribly wrong, it will cope with it. Sorry, I'm going to have a quick drink again. So, how do we leverage mocking? So there are two common ways in C++. The first is interfaces. So this is the one we're really focusing on. Okay, it's all about virtual member functions. So also, first of all, who knows what a virtual member function actually is? What does it do? Yeah, go ahead. Oh wait, actually wait, don't go ahead. Don't go ahead. You can go ahead now.
Yeah, so a virtual member function is a function inside a base class that you would want to further specialized in derived classes.
Exactly. So did everyone hear that? Yeah, was that clear to everyone, or is that a bit too technical? Exactly. Yeah. So, but you use the word virtual on it. So you can have a base class, and not use the virtual keyword, and you can have a function in it. Then you have to implement it. But then overriding doesn't work. Virtual is what enables overriding of that function in a derived class, changing the behavior. You can also do it with templates, though. This is completely doable. You can absolutely just do it with templates, right? You can potentially use the CTAD pattern, right? You can have your class that you're writing, the implementation class, have a template type, and then you'll feed it some class instance. And as long as that class instance happens to have a member function with a matching name and set of arguments, yeah, it would work. It would be fine. You can do this. Nothing stopping you. Probably don't really need to these days. It's cleaner and a bit safer, obviously, if you do it the interface way. It's well defined. The definition is much better. So consequently, we're going to focus on the usage of interfaces as a result. This is designed to be more of a sort of live coding session anyway. And there are, of course, different ways of doing mocking when you are using virtual member functions, right? So we can have a true interface. So that means we have pure virtual member functions. And who would like to tell me what a pure virtual member function is versus a, just virtual member function? Yeah, we got one here from Michael. Did I take the mic? I did take the mic. Let me get the mic.
It signals that the interface of which you're working does not provide an implementation for the function, so the interface cannot be instantiated.
Precisely. Excellent. Yes. When we have a pure virtual, so we stick equals 0 at the end of the function declaration, we're saying that we're not implementing this, because you can make a function virtual, and you can also implement it. It can still be overridden, but the base class now has an implementation, so you can then instantiate the base class if you like. But by making at least one function pure virtual, it now becomes impossible to instantiate that class. You cannot create an instance of that class. And I assume everyone's clear with the concept of classes and creating instances, I hope. Yeah, cool. And so obviously the lazier option, the less structured option, it's not necessarily always bad. Sometimes you might have a slightly mixed class where there's some pure virtual or none, maybe, and some of it is implemented. It's got sort of default behavior, if you like, right? You can use virtual without being pure virtual for default behavior. And if you do that, you can still mock it, right? The mock can override that behavior, so you're still fine. It'll work just fine. So, of course, as a result, you could just mix them, right? Mix and match as you choose. But, and again, this is somewhat opinionated, obviously. I believe that the true interface approach is the cleanest and the best, right? There's no possibility of confusion. It's a bit of cognitive complexity that's done away with, because I know for a fact that all the interfaces I'll ever encounter will never have any functions implemented. I can make that assumption, I'll always know it. It's just easier. Or at least easier to track. So let's continue with the TDD Marking project. So who has done anything? Who was here for the previous session and started doing this?
I'm up to where you finished. If you know what I mean.
Okay, good. So for those of you who weren't, not to worry, I'll do a recap. And if I do start going too fast, please slow me down as well. I don't want to, people who are watching on YouTube, you'll be able to watch this recorded later and speed it up by like 2 times if you like. So yes, do slow me down if I'm going too fast. Yeah. So just let me know. Anyway, so for those who haven't yet, that's fine. I'm obviously going to continue doing it, but if you need the link again, here it comes. So Tom, would you please do the honors with that link in Slack and YouTube? So if you have a laptop and you're sitting in this room, you can go to the Slack, or you can go to youtube.com/CPP London Uni. Go to our live video, and Tom will post it to the chat for us momentarily. It's the same as last week's, Tom. So we're just getting that pasted in. Click on it, see what happens. Yeah, that's good. That's good. No, you're good. Right, so I am now going to attempt to switch the broadcast. All right. That is vaguely the right size. So I probably need to mirror this, don't I? That's a problem. Hopefully this won't mess with the broadcast. Can we move you over? Problem is I can't read it now, can I? Right, we're gonna do a little thing here, and have I just lost? No, it's fine. Okay, we've just lost the signal, even though it's a very long HDMI cable. All right, stand by online, folks. There's nothing wrong with this. Oh, something's happening. Nothing's happening. That would really be bad, wouldn't it, if we lost the HDMI?
Make it a difference.
Is that power? No, that's infrared. Oh, you know what I think's happened?
What?
That's run out of power. That's got a DC 5 volt in. Oh no, is it on? Input 1. Yeah, no, it is on. Okay. That's slightly problematic, isn't it? Alright, those who are online, we're just going to test C-Line for a sec. Yeah, that works. Okay, so the YouTube stream is still fine. The screen is completely... Sorry? No. It did, that is true. But there is no... Well, the audio is still fine, so...
Getting power. So no, it's getting power, so it doesn't need... I think this is if you have more...
Alright, well, we'll move this back then. I'll try mirroring the screen, so I'm sorry, stand by. It's not detecting it.
Guys and girls, if you want
Is there anyone
to
who's
go
around me?
to YouTube, then you can see his screen.
Yes, who's not got a laptop? Okay, Michael's not got a laptop. You can stand here if you want. Right, well, we're going to continue. That is a shame. Let me see what I can do. Hold on, I'm not going to give up just yet. Where does this HDMI lead go?
Yeah, that's the thing.
Oh dear. That is a problem, isn't it? Mm-hmm. Don't unplug that. Don't unplug that.
I was placing this one.
No, that's not to do with it. That's not the problem. This is the HDMI.
How about you unplug this for a second?
That will completely break everything. The audio is working fine. This dongle is here. That is unfortunate. Look, you know what? Let's test if it's me. What we're going to do is I'm going to unplug this. And actually, no, why don't we just do it directly? Let's just get rid of the middleman. Oh, I think we're coming back. Right, get rid of the middleman. That's how you do it. So, I'm going to try and mirror this now. Stand by. I would love to try and mirror it, but I can't see C-Line. Oh, it's moved it to this screen. That's really unhelpful, isn't it? Alright. We will be back in action momentarily. Please. Yes. Okay, everyone can see that? Well, not yet. Not yet. Let me just sort out. Could someone check YouTube? I think the scaling's gone to pot. Oh, maybe it's okay. Right, so let's go to presentation mode. Not now. project.
It's okay.
Cool.
Online.
Is it all good?
Yep. Oh yeah.
Is it good?
Yep. Yep.
100%. Lovely. Okay, so who remembers what you needed to do? So we're going to basically build a C++ version of Blockbuster. I call it Blockbusters. Copyright reasons, obviously. Yeah, Blockbusted, yeah. So we have a very basic framework. There's a bit more done in this code than there was last week, but I'll go through it. And obviously you just need to create a system which will, come on, scroll along, that will manage an inventory of rentable items. And I say rentable items, right? Obviously Blockbusters, yes, they were videos. But you could rent anything out technically, right? We should make a generic system that's flexible and scalable and amazing. So consequently, we're going to do that. And the idea is obviously, we want you to focus on a TDD approach. So with that said, let me get it out of the way. Let's see what I changed last week. So we had our customer header, right? So well, I should take you to the interface first, to be fair. So we have our customer interface. You know it's an interface because it starts with an I. Obviously, that's my choice. That's my style. You don't have to do it that way. You can pick what you want. But for the purposes of this, I decided that all interfaces will have an I in front of them. And it should be fairly obvious what the functions do, right? We have one that returns the customer's name. We have one that returns the customer's address. What did I do with the clicker? I have the clicker. We have one that's returning the customer's balance. Oh no. The laser doesn't work on this screen. No, it doesn't work, look. It's barely visible to me. Let me work around that with a technical solution. Oh wait, I can't, it's not PowerPoint, I'm stuck. Okay, never mind. So we have the balance. We have a vector of pointers to rentable items. So that's the stuff that the customer has rented out. So it will effectively own those rentable items for as long as they're renting them. We have an adjust balance function, right, which takes an instance of the money class by value. We have an assign rental, obviously so that we can, add to the customer a rental that they're paying for. And we have remove rental, which takes a size t because it will remove the rentable item via its index. And then, of course, we have a virtual destructor, which is obviously defaulted. Anyone like to tell me why that is a virtual destructor and not just a normal, or why have I bothered to declare the destructor?
So you delete the whole of your tree.
Yes. So if anyone happens to need to delete an implementation via the base, via the interface, having a virtual destructor ensures that the implementation's destructor gets called. It's just for safety and correctness. We then have iRentable. So this captures most of what a rentable thing would have, right? So if you imagine something that you can rent as a title, if it's a video, it's going to be the movie's name. Might be a boat though, might be the name of the boat, right? There's the type, video obviously, could be boat though, or anything else. We have the start time. So you call rental start, it will return the clock time when the rental was started. We have rental end, which of course returns the time when the rental is going to end or has ended, depending on what the time is right now. You have the cost of the item per day. So, really old movies might be £2 a day. Modern, brand new movie that just came out, that's just gone to video, it might be several quid a day, who knows. We have a penalty per day, so the amount it will cost you if you don't return it on time. We have, of course, then functions that let you set the start and end time. So obviously when the video is being rented, you will need to set the start time and end time when someone takes it out. You'll check them once they return it, see how much they have to pay. And then when the next person rents it again, you can obviously update the rent start and rent end. When it's not being rented, it doesn't matter. You don't care. So we of course have our money class. So originally you'll find that it only has pounds and pence. I added a couple of operator overloads a couple of weeks ago in the previous lesson. So you could compare if the money was the same amount. So, you know, the pounds equals the pounds and the pence equals the pence. And I made it so that you could conveniently add one money instance to another. So you obviously add the pounds of one to this one, and the pence of the other to the other one, to this one. Sorry, what was the...
Why are there no exceptions added on that specific class?
Alright, so the question was, why are there no exceptions on the operator overloads? That's because they can't throw exceptions. So I might as well declare them no except. You don't have to. There's no requirement to. But how can you possibly throw an exception just by comparing two numbers and just by adding two numbers? There's no physical way for how could this line throw an exception? How could an exception be thrown from that line? It can't. Right? This is an intrinsic instruction that just checks some numbers in the CPU. And this is just an intrinsic instruction that adds two primitive types. There's no capability, no possibility of a long or a char throwing any exceptions. They're just numbers. They're not a class. They don't have any concept of exceptions. So, just to annotate them nicely, I made them no except. You don't need to. It's just efficiency and style. So then we have our video class, right, which is an implementation of a rentable thing, because of course a videotape is rentable, right? I can rent a videotape. It has a constructor. When you construct it, you need to tell it its title, so, you know, Gone with the Wind, who knows, whatever. And the type, film, TV series, whatever it is. And then, of course, it now needs to declare the same functions that are in the interface. So, of course, there's the title. And we have that nice override keyword there. Who remembers what override does? It doesn't do nothing. It's not quite nothing. Mike, let me get you the mic. In fact, Tom, you keep hold of this.
Hello. Okay.
It's very sensitive, so it doesn't need to be.
Override throws an exception if it doesn't find a corresponding virtual function to override.
Almost. You said throws an exception.
At compile time.
Fails to compile.
Fails to compile.
So you don't throw exceptions at compile time. Your compiler just stops and says error, compile error, bad code, stop, and it won't build your code. Yes, it is a nice safety check. You don't need it, although if you forget to put it on there, you usually get a warning instead saying, you didn't put override on this. You probably would like to. Please do it. I won't stop you from compiling this, but you probably want to put override. So consequently, so that we don't get any warnings like that, we stick it on there. So we have the title, the type, the start time of the rental, the end time of the rental, and then finally the two functions that let you set the start time and the end time. Is everyone clear on the difference between... Oh, I can't use the laser, can I? It's terrible. Does it? Oh. So I'm just going to point my finger. So everyone understands the difference between these two here and these two here. Yeah? The top two and the bottom two, rental start, rental end. No? Okay, Michael thinks he does, so what's the difference?
It's an overload of the function with a different, how shall I say, with a different signature. So
Yes.
the one sets the time, the other one takes the time.
Precisely. So you'll see that the first two, rental start and rental end, have the const declaration at the end, which means they are the read-only overload, right? They will only read what the current start and end is and give it back to you. Whereas the second two, they don't give you back anything. They just set it. So one is for reading, the first two are for reading, and the second two are for writing. And then finally, we have the question, please.
Wouldn't make like, I don't know, to make it easier, let's say combine them together. So for example, you have one signature, yes, which returns clock time, but if you provide an argument, then that sets the time. But if you provide without the argument, that will just read the time.
So the short answer is no, because you can't. Would anyone like to have a go at expanding on why you can't do that?
I would say two reasons. First of all, you could mess inside the code if you're checking whether you actually provide an argument. And second, what do you do with the return type? You need to return something.
So those are not bad answers, but they're not what I was looking for. You could ignore the return type, right? If I did do what he's saying, so I made these take the argument, they can also return the argument. So if you somehow pass a null version of this type, which is not really great, but say you did because it's defaulted, then I could just ignore it and return back the current value down here, right? So the start and the end. If you do pass one, then I'll just give you back whatever you passed me. It's possible, but it's not good design. But there's a more intrinsic constraint that makes this impossible. Anyway, in terms of the feature set I need.
You won't have a clock time to pass.
Sorry?
You won't have a clock time to pass.
Oh, I have a question.
You won't have a clock time to pass.
No, you always will, because you either have the one that it is currently or the one they pass. You will always have them. It should light up when it's on.
So I think the problem will be the const that if you put it in one method, then you can't use the const because it will modify.
Precisely, that's what I was looking for. Yes. If we want to combine them, that's not very useful because now I can't have a const instance of either of these, of either video or iRentable, and use them. It can't be const if it's allowed to mutate it. There is a special exception. You could be a really, really clever Git, and you could put mutable in front of those two, but that's too clever by half. Just don't do it. Silly. Crazy. So let's look at our implementation, where we're at. So hopefully I can bring up the tests as well. No, it's one at a time. Okay, whatever. So you can see we have a body of tests here, right? And the first thing we've done is we've made a mock rentable class, and I believe this is actually where we left off. We didn't, I don't think we quite got around to using the mock just yet. We may have done actually. But you can all see that we have trompe l'oeil with the mocked functions, right? It's a fake version of Rentable. We have some test cases. So, you know, if we construct an instance of a customer called Judge Dredd, and then we just have a reference to the interface from this, right? This is not the line here, line 28, is not creating a new object. It's just upcasting it to the base interface. We can then just require that the name that it returns is actually what we originally fed it. And then, of course, we've got some code to verify that we can have a mock of the rentable. So, as you know, this is where we are using the mock, right? So, does anyone remember what the Death Watch thing does? Precise. Oh, yeah, go ahead. One more time.
It checks that the object we allocate gets destroyed.
Yes, exactly. This is part of the testing framework. We require that our mock of a rentable item will be destroyed. So we create a customer. We then have, again, we cast it to the interface. You don't really have to do this casting to interface business of taking a reference to the base, but I like to do it this way because we can utilize it through the interface, and it's just a nice, it's a clean way of testing. So we then use the interface to assign a rental, and obviously we use move to give them ownership. They own the rental. We then verify that by doing that, the number of rentals they have is exactly 1, right? So we've constructed them here, and they had no rentals, we then gave them a rental. So then it should be 1. If I wanted to take it a step further, I could verify that it's 0 here as well, just after construction. But we then remove the rental by its index, obviously in C++ or in most sensible languages. No bias there. Indexes start at 0, in my opinion. If they don't, then your language sucks. I am slightly hypocritical there because I do like Lua, and Lua starts them at 1. But we then check that it's deleted it, right? And of course, so we have 2 final checks. So once we fall out of scope here, this will either have succeeded or failed, so we'll make sure that this thing was killed off. And then, of course, just some basic stuff to make sure the rest of it was implemented correctly. I think this was when I was running out of time, basically. So we have another implementation. Again, I cast it down to up to the base, the interface. Check the name, check the address, right? So we fed the address in here. Check the balance, right? So they should have no money at the beginning. And then we adjust their balance. We give them £3.46. We then check that they have £3.46. We then adjust it again. We take off £1.16. They should have £2.30. Make sense? Yeah. And actually, does anyone know why I've elected to use an actual type here with pounds and pence rather than, say, a float or a double? Why would I? Because I could have 3.46, couldn't I? So we've got 2 quite. Tom. There's 2. Yeah, Michael first, I guess.
Yeah, it's very unlikely that you will find equality between 2 floats because of the precision errors, rounding errors that could accumulate.
Michael says floating point imprecision. Are you going to say the same thing?
Yeah, I think is the same. So I wouldn't say you won't find, but that there are some counting errors in it. When you do one plus other, sometimes it's a bit different.
Yeah, precisely. Do not use floating point values unless you're genuinely doing some real math where it legitimately needs floating point values. I have pounds and pence. I have no reason to use floating point values at all, right? Yes, they are a subdivision, but I can record them separately as a whole number. And that is exactly what I do. My favourite story of the abuse of float was an American chap who used them to store telephone numbers. He used, because in America the country code is 1, right? If you ever looked at an American telephone number, when they write them internationally, they use a dot. So they use 1 for the country code and then a dot. So he thought, I'll use a float then. So you'd have like 1.555.226.7479. That was how he was storing phone numbers in floats. So obviously there was a bit of a rounding error with some of those phone numbers, shall we say? Yeah. Anyway, one of my favourites. I think that was from the Daily WTF, in fact. So we have the main's not interesting at all. We have the header. We've gone through it all, right? I think that is actually everything in there. So. I missed the video. I did miss the video. So this is now the implementation. These are all basically boilerplate, right? When you see what they do. Maybe someone's a bit confused by line 14 though. Does anyone want to tell me what I've done here? It's not quite an auto return. Oh, Michael's got it.
It's the alternative return syntax.
It is. It's the alternative syntax for the return type, where it's called a trailing return type. So rather than putting it at the beginning, I can put it at the end. Okay, so that's a good answer. But does anyone know why I did that? Why did I make it a trailing return type? No, not. What do you mean by nicer formatting?
It
If
just
I hadn't done it, what would be the difference? If I didn't do that, what would be the difference?
Um,
No, the type would have to be the same. So I'm just saying, if it was not a trailing return type, so I put clock time at the beginning, what would the difference
I
be?
think it's because of the const.
Nope,
Okay.
not because of the const. Let me show you clock time. I'm maybe not being fair to you here, so where did I stick here? Yes, here we go. So there's clock time, right? It's an alias, yeah. So does anyone know now why I did it as a trailing return type?
So you didn't have to have the whole of the name.
John's got it.
So you didn't have to have the whole of the name with the double colon quotes things.
Yes, precisely. If I wanted to do it the other way, I would have had to do it like this. It would have been rentable colon clock time video rental start const, which is perfectly legal, but as you can see it's a bit longer. There's actually not much in it, but it's a bit ugly, so you can't really you can't misread that, so I prefer it that way. It's a matter of taste, obviously. Why would I not need the namespace at the end?
Yeah.
Because the compiler knows now who the function belongs to. When it's at the beginning, when it's evaluating it, it doesn't know whose function it is. But when it's at the end, it knows everything now. It knows, oh, it's this guy's function. So this is now in scope.
Thank you.
Right. So, is everyone fairly caught up with all what we've got so far? Who has cloned the project and is ready to go? Nobody's cloned the project. Oh, you're okay.
Well, it was, yeah, I think, unless you've changed it,
No, this is the same as a couple of weeks ago. So I think we sorted out the customer. We wanted to get onto the video class, I believe, or did we? Did we sort that out? Why did I implement this? No, it's because this was the framework I gave you. So this one doesn't need testing because it's the basics. So let's see. Let it be rented out to people. Need a charge. So we need to think about what the most sensible class to offer is next. So currently, right, we've got a customer. We've got a video object, right? We have the interfaces that represent a customer, and we have stuff that's rentable. What's the next thing we probably want to do? Any suggestions? We could have an inventory, a library, yeah. We could have a library or inventory of items. It's not a bad one. That's very tempting to me. I'm actually asking you guys a genuine question here because I have a few options that I can think of, and that is one of them, yeah. A second one, anyone?
Do you need a shop balance?
A what?
Do you need a shop balance of money?
Do I need a shop balance of money? Yes, that's also a valid one. You probably want to have something like a cash register, effectively, like an accounting system. I'm not going to go with that just yet, though, in this case, because it's not quite as interfacey as I want to go. The whole point here is mocking. So what I'm currently erring towards is we basically want something that will take care of rentable stuff and loaning that stuff out to customers, right? We probably don't want to make it responsible for too much. So as John just said, we probably don't want to make it responsible for the accountancy as well, because it's going to be one class doing far too much. But it arguably makes sense to have a class that is going to take videos, rent them out to a customer, right? And its responsibility will be that when it rents it out to a customer, it should probably set the start and end time of the rental. Yeah? So, let's start building our class. This is effectively a controller, yeah. So as I usually like to do, we'll call it test rental controller, and I won't create the implementation file just yet. We're going to stick it all in one header. It's just much easier that way. So, and this is now where we really get into separation of concerns, right? This does not need, oh, that's not good. This does not need to know about the rental, the video class, and it does not need to know about the customer class either. There's no reason for it to know about it. So it can just know about these interfaces, right? So we're going to include iCustomer, or interface, sorry. And we're going to include interface slash Rentable. Allow our stub class. And now we can start writing some tests. So we'll include catch.hpp. I'm going to remind myself you have to include Trompeloy first. No, afterwards. Right, okay. So good. Okay. So let's have a test case.
Why the includes you have below class?
So I'll explain why. Yeah, sorry, I should explain why I do this. So when I first work on doing an implementation, I could put them in separate files, right, immediately. I could go and create a rent controller class here in the source folder, and I could have the tests here in the test folder. But there's not enough code really to justify it, right? It's pretty small. So what I do is I first start writing what I'll want for my actual implementation. So up to line 7 is the implementation at the moment, and after line 7 is the test code. So consequently, those bits come after, because once it gets big enough, I can just drag, cut, and paste into a new file. So I keep them separated for that reason.
So basically, if you put something below from line 8, like there will be a separation. They won't see anything from the lines from 1 to 7.
It's a separation. So testing starts. Yeah.
So the class rent controller won't see the catch and so on stuff, the Trompeloy.
Well, I don't care if it does. That's not my concern. It's just that I want to be able to very quickly cut this out of the file and paste it elsewhere later. So I can just drag, and it's very easy to do. It's just for me to drag the mouse quickly later on. That's all it's for. But yes, it does have that effect as well. You're absolutely correct. That is also an effect, but not what I'm concerned about.
I think that class should be rental controller.
Sorry?
Because the class should be maybe rental controller, because the file named is test rental controller.
So that's a good semantic point. That yes, I should do that. However, unlike, are you a Java developer by any chance? Yeah. C++ doesn't care. But yes, you should be consistent nonetheless. But unlike Java, it doesn't matter. So let's have our initial test case. A video. We can't. Let's not say video because we don't have that concept. And iRentable is correctly dated. Let's capitalize that. Dated and given to a iCustomer. Does this one make sense? Does that idea of it, does this test case make sense to everyone as a concept? Right? We have something that's rentable. We have something that's a customer. It could be our existing customer class. We might make a business customer class later, right? There's different kinds of customers. Some are people, some are businesses, whatever. So, consequently, we're going to have it do this. So, first we need to instantiate it, right? So, I'm going to comment this as I go. Given a rental controller, don't freeze on me now. Any suggestions on what data I might need to construct a rental controller with? Probably don't care yet, do we really? It needs to know customers. Or does it? Maybe you could have just a function on it that will take a customer when you call it.
I think you can set up even random, like from the current time. Put it as a variable, and then do the checking against the result.
Yes, because so you're saying we should give it a current time as a constructor option. See, I would say no to that because I think that once you've instantiated it, it's probably going to live for the duration of your system. So if you give it on construction, 2 days later, it's got an old time.
In rental control, it should know what's available to rent. It should know what's available
The rental
to rent.
controller should know what's available to rent. Yes, I like that. I agree with that. So we probably want it to take a vector of iRentables. Make sense? But then then now we've got an interesting question, because if we wanted to take a vector of rentables, how are we going to design for telling it which one to rent out? By index? Do we want to do it by index? There's many choices.
Do you not need a flag on the rentables? The true or false, whether that rentable.
Well, see, we could get deeper and we could say that actually it could take a reference to an inventory manager, and then that would manage it, right? And that would be responsible for querying. So for simplicity's sake, I'm going to keep this class basically invariant for now, because I do like your idea and I want to make sure I can implement that later. But for now, we're going to keep it relatively simple. So actually, I think we're going to say that we'll just let it be default constructible.
Couldn't you put? So I'm probably going to make the video really complicated. So
Okay.
the video class would be, as well as the title, rental start, rental end. Would it have a rental out flag, a rented out flag?
No, we solved that problem, because when you rent it to the customer, you take ownership of the object. The object's life gets moved on to the customer, so it doesn't need a flag anymore because it just physically lives on the customer.
But how do you check that it's?
Because it won't be in your inventory, right? You'll move the object out of your inventory onto the customer because they physically have it.
Okay.
Right?
Okay, so it'll be out. It'll be removed from.
It'll be
the
physically removed from the inventory. Yeah. Tom's got a question. Not Tom Parvis, sorry. So Tom Parvis has a question.
So if you do that, I mean, sorry, I missed the beginning, so my apologies for asking a question that's been answered already. But if you move the lifetime management into the customer, and do you have any other mechanism of knowing if you wanted to find out which videos are rented out? Would you have to go through all your customers to find them?
So the short answer is currently there's absolutely no code for that at all. So obviously the short answer is no, we can't. The longer answer is, well, yes, we could do that, right? When we move the ownership to the customer object, we could of course keep a reference, right? We could keep a list of references to whatever's owned by various customers. So yes, it's still doable. The part of the reason that I elected to design it this way and physically move it around, because it's basically moving a unique pointer, right, was, I mean, mainly as an academic exercise. I'm not entirely sure I would choose to design it this way in real life, but it adds a little bit more, gives you a little bit more to learn and think about, right? So, given a rental controller, when we rent out an item to a customer, so probably needs a name, doesn't it? So we'll call it RC. And then we'll do RC dot issue rental. Well, we need an item first, don't we? So that means we need a mock. So as it happens, we did make this mock here. So one thing I like to do, and I'm going to do it now, is that this is currently living in the test customer class, test unit, right? We want to reuse it, so let's be sensible, yeah? Let's make a folder. We'll call it mocks. And we'll just gut this code. Wrong key, X. And we will stick it into a header. I've forgotten what class was it? I've forgotten. is it mock? No, it's mock rentable. Right. So we'll create a header. And I am a man of pragma once, thank you very much. Cool. Not exactly there though. No, that's the wrong file, sorry. We'll now need to include it, and it's going to depend on trompe-l'oeil, so we'll just cut that out. And mark rentable. Thank you. It loads. Interface slash. Right. So I don't care about the paths just yet. Beautiful. So now we have a reusable mock for Rentable. So in our tests, actually don't need this now. We have that. So we can now do mock Rentable ML. No, we can't because we need unique pointers. Mark rentable. And, well, what else do we need? Should be fairly obvious, right? A mock customer. Right, so who would like to work through with me on creating this mock customer? So you can see mock rentable here, right? So yeah, you need the includes first of all. Yep. So we can copy that. Oops. Okay, so you can see from here we have, well, you know what, I'll just copy a few of them as an example. So let's just take these two. And I'll just bung them in as a comment. Okay. So, need to make it public, obviously, right? So then, just for convenience, I'll go to iCustomer. We'll just nab all this stuff. And I'll paste that in as a comment as well. Right, so you've got an example of some mocks. So the first one we need to mock is the name. So what do I need to write for that?
Make const mock 0
Make const mock 0
name.
Now he's thinking. So
Yeah,
yeah, obviously it returns a std string, yeah, but a bit more detailed than that.
Yeah, reference to std string.
Do you? Thank you. Const std string ref. Const std string ref brackets.
Override.
Hold on, thanks. Yeah, we need the override argument as well. Why is that complaining at me? Oh, I think it's just being silly, isn't it? No, you can ignore the errors. It's because it's in the mock folder. So at the moment it's not part of the project. So Catch doesn't know where it's at. If I add it here, it should start behaving itself. There you go. Right. Yes. So are you clear on why what these arguments are? So this obviously declares the mock function, right? So it's obviously the name matches this, and matches name up here on line 12 for those watching. And do you understand why it's const string ref and the empty parentheses? Because the return type is constant string ref. So on line 12, it returns constant string ref, so that needs to match. And of course, the third argument being override is because we want to mark it as override. So what is the question was?
What was the mock 0 again? I've forgotten from last week.
Not one argument.
Zero argument.
0 arguments, exactly. This mock function does not take any arguments. That's why the parentheses are empty here. And of course on line 12, name has empty parentheses. It doesn't take any arguments. So we'll repeat that again. For the, address. And what's the next one? Thank you. Sorry? I do. Alright, so what's the next one? The balance. Make mock 0, exactly. Balance, money, no. Sorry? Okay. Who would like to have a crack at the next one? Virtual. Oh, you're right. Sorry. Anyway, it's not going to compile anyway. It needs to be const. Yeah, who wants to have a go at the next one? It's not that scary. Just look at it. Make const mock, yeah. Yeah. Rentals. So what do I type? Well, what's the type? Stud, vector, stud unique, pointer, irentable, ref. Bracket. Yes, exactly. Okay, and then I think you are correct. So next one. Go on. It's no. It's returning a const reference to a stud vector of unique pointers to rentables. It's a vector that has pointers to rentables.
Doesn't the pointer return the reference anyway?
If you dereference it, yeah, but this just holds that type.
So why do you need the and?
It's like layers of an onion, right? Like so, this is the deepest thing, right? The rentable. Yeah. This then wraps it as a pointer. This then holds multiple of them.
Well, what I don't understand is actually it's not the mock, it's the actual function. It's like you're returning a reference, you're returning a pointer.
No, you're not. You're returning a reference to the vector that holds them.
If you wouldn't do that, it would copy the vector
Yes.
and every element in it.
Which would fail to compile because you can't copy unique pointers. Alright, so who wants to do the adjust balance one? It's fairly simple.
Make const
No. Make mock 1. Yeah. Beautiful. Excellent. Very nicely done. So obviously the rest are fairly straightforward as well. So we'll do make mock 1 again. Assign rental. And again it's void. Oh, no. So this is the return type this time, so it's the other way around. So it stood unique pointer I rentable size t is the argument, and that's it. We have a mock. Question.
A question about the implementation here of the interface. So the void adjust balance takes a money object, and
So adjust balance takes an argument of money.
yeah. So it could have been something like a const reference to a money object, for example. Is there a specific reason you chose passing an object here?
It could have been a const ref. Absolutely. The reason that it's by value is because, well, look at it. It's got a long and a char in it. It doesn't matter. It's such a trivial type. You don't really need to bother with a const ref. So we take it by value consequently. But yes, a const ref would work fine. So I've got lost now. Where am I? Mock rentable? No, mock customer. So we'll get rid of this cruft now. We don't need it. We've got what we want. So yeah, we've implemented the entire mock. So let's start using it. So if we go over to test rental controller, we obviously want an instance of it, so we can have auto mock. I can learn to spell. I love it when the variable names line up. It's very satisfying. You know, my inner OCD is really happy about that. Mock customer. Okay. So then obviously we're going to issue the rental. I don't think I care which way around I do it. I'm going to say that we'll pass the customer first. And that's basically going to do it, right? Its job is to issue the rental, have those two objects interact. We're done. We're not quite done, actually, because there's some ownership required, right? The contract of the customer is that it's going to own the rentable. So as part of my design, we're going to need to std move it, right? We're going to give it ownership of the rentable. So now we're thinking of designing for testability, right? What do I want to verify, right? Then the customer should, well, actually no, we don't want to test the customer, right? That's an interface, so that's a bad decision. We should then the customer should have been called with sorry, go on, Michael's go on.
No, you just decided not to test the customer, so I would have said you would want to know, you would want to verify that now wherever it came from, it's empty. The mock rentable is empty, and the customer has it.
Don't test the rentable. Oh, actually no, sorry. Okay, no, you don't mean that this is empty. You mean that the unique pointer is empty. Yes, that's good. That's a good one. Good test. absolutely. So, but there's a bit more we can do before that, because the whole point of this is mocking, right? We're focusing on mocking. So I should be verifying that issue rental is going to call the appropriate function on mock customer, right? That's what I really want to do. So we have to do it beforehand, so you need to actually set these up beforehand. So when I'm doing this in a very BDD style, so we'll say that when we create some mocks and expect the customer to be given a rental, so expect, that's not expect, is it? What was it called? Yeah, I've completely forgotten what to do, so give me a sec. Let's... Oh, this is what happens when you get ill. You forget everything. So, make mock, yeah, that's... request, what I was looking for. Require, cool, thank you. So, require, cool. Come on. Good. And obviously it's a unique pointer, right? So we're going to do the dereferencing. So you have to give trompe-l'oeil the reference to the object. And I've forgotten again, call, and then it's actually the function. So what do we have in mock customer? We have assign rental. Sounds like the one, doesn't it? So I'm pretty sure you can use underscore. Please say you can use underscore. Yes, we have to include it, don't you? So. One sec. You are correct. So now we've got a set of member functions on this. So why is this not playing nicely? Let's look at the reference cheat sheet. Cheat sheet. Maybe the cheat sheet's good enough. So well, let's just think about it for a second. So obviously we're gonna call assign rental, right? So before I go and look up the syntax, what do we want to verify with this mock? Obviously we want to verify it's cool. We've done that. What else do we want to verify? Verify what? Precisely. We want to verify that when assign rental is called, it should be given this thing, the mock rentable object, right? So let's have a quick look at the old cheat sheet. That is not what I was really looking for. No, that's too simple. That's too simple. Reference. Let's see. Implement, name, require. See, one thing I'll tell you about programming is there's stuff you never memorize. So don't care about return. Use a matcher. Well, we can compare the pointers, can't we? Yeah, that's not bad, is it, I suppose? So what's that star doing, though? So we have mock obj in their example, which is a C, func, and okay, I see. All right, so we can do that. So, is this happy? Copying. Oh no, it's copying. I can't use that. Okay. We need something. We need something a bit more clever. Sorry. So I'm going to require the call. I'm going to require it. So if you do allow, but it doesn't get called, it won't fail. If you do require, it will fail. I want it to fail if it's not called. So the catch is that we need something that will let us execute a bit of code, really. Perfect with. That's exactly what I want. So first of all, I need a reference. No, I don't want a reference. I want the pointer value. I want the pointer value, right? So we'll just do underscore. And yeah, that's good. But I need the pointer value first, don't I? So we can say auto pointer value. Why is that failing? Whoop. That is an error that is so big it can't even print it. Let's just build it. We've got a good start here. It can't find cache.hpp. Let's just do /. Same again. What's the error? What's the error? Oh, let's see. Use of undeclared. Oh, I can't spell. That's the first error. That's always a good one. Typos are a way of life. But they're also easily fixed. So they don't matter. Okay, got another one. Let's see. Use of undeclared identifier mock rental. I call it mock rentable. Alright, fix that one. And okay, now we get on to more obvious errors. So there is no actual member called issue rental. I never actually created it, did I? So I think C-line is just stupid because it's not complaining about that. It doesn't seem to be. Oh no, it is. Here we go. If I was random expression, yes, of course. Can you do this? You can do that. That's very nice. I like that. Brilliant. I love it. Is everyone clear on what this _1 represents? It's obviously a bit of macro magic. It's some macro magic that lives in trompe l'oeil. It's just the first argument, right? So this underscore represents the first argument, and then I can use this to verify it's equal to the pointer value here. So it's a feature of trompe l'oeil, right? I have an argument this takes, so trompe l'oeil magically creates a variable called _1 for me that represents this first argument. So whatever the first argument is, that's the name of it. Yeah. It's part of the framework. It does exactly the same thing that it did here. It gets the underlying pointer that the unique pointer object is holding. The raw pointer, it gets the raw pointer. Sorry? So it is, I'm sure it is, but I don't actually want to do that because the problem is that, well, we'll be move constructing from one instance to another, and I doubt they'll compare equal. They won't compare equal for equality because by the time this is called, this is going to be empty. This is guaranteed to be empty. So the equality comparison will fail, or at least we expect it to be empty. If the code's wrong, it won't be. So let's have our public. If I can learn to spell again. I think this butterfly keyboard on the Mac doesn't help. Sometimes it registers keys twice and awful. Anyway, So we have a rent controller. We're going to do, well, issue rental will be void, I guess. It makes sense for us, or at least for now. And then it can take a stud unique pointer to, what have we got to hand it? Let's see. Well, you know what, the mock customer, does it really need to own the customer? It doesn't really need to own the customer, does it? If we think about it. Not necessary. So we can do it by value. We will simplify this down and have that by value, right? So then this could just take a reference. Why does it?
You've got somewhere you've got the link customer with your video that you've rented.
Yes, but why would we need to do it here?
Well,
I'm not saying we don't.
the question is like where were you?
Yeah, it's a good design question. I think that at the moment I'm kind of undecided, so I'm focusing on tackling the test case in terms of its pure set of functionality, right? So I'd rather not address the question now, just to get a working base. And I'm not designing this in a way that I'm going to hamper myself later anyway, right? If I decide I want to do that, I can. Equally, if I decide I don't want to do that, I don't have to. So we'll take a customer, and of course we then need the unique pointer. Rentable, of course. This is again also why I moved the mock stuff down, because I can't accidentally write mock rentable up here. It wouldn't compile because it's only included afterwards. Nice little bit of safety. And there you go. We have a function. Brilliant, right? So if I build it, it should fail horribly. If I can get it to build. Let's see, in direction. What's this? In direction requires. What's it whining about? Oh, my fault. My fault. Don't need the direction. Yay, we built it. Run it. Yay, we got a failure. So let's see what's gone wrong here. I mean, we expect a failure, right? Again, this is red, green, refactor. We are on the red phase. So, an iRentable is creating data into a customer. No. Actually, no, we're not done, are we? We haven't fulfilled all the tests. Then the date of the rental should be set. Ah, we're missing something on the rental, aren't we? We need to tell it. We need to tell the issue rental how long it should be rented for, right? Makes sense. So we need more than just this, right? This is insufficient. So I'm going to add another argument. And basically, the start time is implicit, right? Surely when you call this, it's just immediate. Maybe we might add an overload later that lets you retroactively rent stuff out. At this point, I don't think I want to. But we do want some time point, right? So this is where we're gonna want clock time. So was it an iRentable? I believe it was. Yeah, it's an iRentable. So if we go back to the test, we can have iRentable. Makes sense, right? So we can then. What was the type of clock time? Because I have completely forgotten. It's a stood chrono system. Okay. So, get the test. Is anyone here familiar with stood chrono? Nobody? Oh, really, Tristan? A little bit. Alright, let's see how familiar this is. So, if we have, I don't know, obviously system clock, right? So we'll have auto expiry is what do you reckon? 100 minutes? It's not really realistic, but it's a test, right? That's not going to work. How can I make that work? How can I make this cool little literal thing here work? I want to add 100 minutes. I think you're right. I think it is min, actually. No, don't do that. Okay, it's frozen. Brilliant. So it's as easy as... And yes, it is min. Really hate this keyboard. Okay, so that should be good, right? So it's going to expire in 100 minutes from whenever now happens to be. Make sense? Yeah. We can make that a bit shorter, actually. I think, is this some kind of class? I think it's a class. Okay. So we have our expiry. What do we want to verify? The rentable should have had its date set as well, right? So before we even worry about the customer, actually, no, let's do that afterwards. So it's supposed to set what, the start and the end time, right? So we can say on the underlying object. And what was it called? Rent start, was it? Rental start, rental end. Don't freeze again. So what do we want to do with the first argument in this case? What should the start be? It's a little bit slightly tricky here, because if this test runs a bit slow, this could potentially blow up in our face, right? No, you can't make them equal, but there's something else you can do. There's one thing that's tautologically true. Can you round up? Don't need to round. You don't need to round, Michael. You can just check if it's after. Precisely. It's less than or equal to, right? Yeah? Makes sense? It can't be in the future. We can make sure it's in the past. If you want to be really strict, we could also check that it's no more than so many milliseconds from now, right? You wouldn't expect it to take too long. But, you know, this is an academic exercise. Well, we can set up a start time at the beginning, but then it would be the opposite direction, right? We don't know how fast the CPU is going to execute this code. Ah, yes, I like that. Yes, so technically, if you want to get really strict, we could record the start time, call it, and verify that it's after the first one, but before the second one. Absolutely. So, I think I'm happy with that, right? That's pretty reasonable. And then the end time. Well, this one should be straightforward, right? Should be equal to the expiry, right? It's got to be equal to the expiry. It shouldn't be anything else. So, of course, we have a slight, well, not really an issue, but we need to move this. And you can guess what that's going to need to compare to when it loads. Come on. Oh, this damn IDE. where? Expiry, right? So is it clear what we're verifying at the moment, right? We check the customer gets assigned rental called. We check that the rental start and rental end is set up appropriately. Is there anything else in the mock we need to check? Yes, no? Who thinks no? Who thinks yes? Who thinks yes? Who thinks no? No, because the money's on the rentable. Remember, the money part is on the rentable, which is mocked at the moment. We don't test our mock. You never test your mock. I do not want to test this thing or this thing. They're mocks. I want to test my my rent controller. That's what this is for. So I think at this point we have basically a pretty comprehensive test, yeah? So let's run it. Obviously it's an empty function, so expect a load of stuff to fail. And sure enough it does. So let's work on this. Usually I would just fix everything at once, but you know what, we'll do it one at a time. So the first problem we have is that we never call rental end. Well, we can fix that, can't we? So we can do the first one done, right? So let's see where we're at now. Rental start. Never called that. Come on. Precisely. It's an operator overload technically. Unique pointer is a wrapper class, but it lets you use it like it's just a pointer. So let's do something stupid. That should fail, right? I shouldn't be allowed to do that. Should I? Because you verify the time, right? So it should have been wrong. So let's see what happened. And you can see the raw bytes of the value if you're really interested. But it failed because it wasn't less than that, was it? So obviously we're going to do stood. So now that should pass, right? We should be a step further. So we are a step further. Never calls assign rental. Easy enough, isn't it? So, not adjust balance, thank you. I think that's enough to make it pass the test. Woo! Done it. For all that test code, we've now at least written a correctly functioning implementation, right? And that's basically what we want it to do, isn't it? We want it to set the start and end time, and we want it to then put it on the customer. And our test verifying that, right? That's TDD. I know that's correct. It's just started passing the test. So I could do a bit of cleanup, but there's not enough. Yes, go ahead. Question.
So just to understand what happens actually with the mocking, so all the calls to require, they're actually like when you mock the interface, I assume you're kind of creating empty functions that you are filling then with all the calls to require, and only when then issue rental is executed, you collect all the information to the function calls behind the scene.
Yeah. So.
And when you go out of the test case scope, it dumps it.
Almost. I'll give you more exact. So what you're asking, I think what you're asking, right, is that this requires it to be called, right? And we haven't called it yet. It's going to happen. So we require it to happen. It's only going to happen on this line, yeah. It's only going to happen on line 44. But then at some point, if this doesn't call it, at some point this has to know that it's failed, right? Yeah. So the way in which that happens is actually incredibly simple with trompe-l'oeil. It's different for Google tests, but for trompe-l'oeil it's very, very simple. It will succeed or fail when the object instance goes out of scope. So when your mock class instance gets destructed, in the destructor it will then verify it's the last chance saloon, right? If these were called, it's all good. If they weren't, you get a failure.
Then it's essential to keep it all in the testing context.
It's essential that you keep your mock instance alive for as long as it needs to when you call the stuff on it, or it will fail. So do not destroy your mock until after it should have been called, is the short answer. And so, we've checked all that stuff. That's good. We could check the rental date, actually. The tests are verifying the mocks, but, we could probably check that. So, actually, do we need to? No, we don't really, so we can just move it. Obviously the comment doesn't do anything, it's just for posterity. Okay.
In your code, the source code itself that you're testing,
In the implementation code.
in the implementation, yeah.
So scrolling up to here, yeah.
If you change the order, does it still pass your mock test?
Well, let's try it. What would you like me to do?
I want you to assign it first,
You
because
want
that's what your mock does.
I know what this is going to do. Does anyone want it? I know exactly what this is going to do. Does anyone want to predict what's going to happen there? Michael?
Well, I have nothing in the Rentable to call the functions on anymore. It's empty.
It's going to crash. It's undefined behavior. Oh! Crashed. Not nice. Right, you'll notice one cool thing. You still got test output, didn't you? Isn't catch clever? You crashed your program and it still tells you. Brilliant. So yes, that's obviously undefined behavior. You emptied the object. Is everyone clear on why that would crash? Not now, I fixed it, but when it was at the top. No. So if I put it back the way it was, right? So just so you're clear, why does that crash? I know you know. The rentable variable. Yes, it moves it. It gives ownership to the assign rental function. So after we return from line 9 and we move on to line 10, our item is a null pointer, empty. So we have nothing. So you can't call functions on nothing. It's illegal. It's a fatal crash. So that is why it died. So what do we got? So we verified now that we can assign rentals. Give me ideas. Come on, what do you think we should do next as a subsequent test? This rental controller. You can issue a rental. Return a rental. Excellent. Yes. A rental controller. So it just takes back.
a general question. You don't need to stop coding. But I mean, the way that you structure your tests right now, it follows a certain narrative. I imagine that when you're, for example, writing a library that is way more technical and has
Detailed or whatever, yeah.
more engineering components in it, that you then it's more difficult to follow this kind of narrative.
No, not really. I still come up with object-oriented paradigms for what I'm doing. So, you know, I might have like a, what's a good example? Let's take TLS for example, right? SSL, TLS, it's TLS these days. You know, there's a handshake phase, right? So I'll have a handshake class, right? And then I'll have, once you get over the handshake part though, you might go into an active session. So I'll have an active session class and I'll put a bunch of stuff around that to do the handover of the TCP socket and everything to the active session state. And as I'm writing tests, it's all actually very similar, really. You know, given a client who knows TLS and, you know, my server-side implementation, when the client connects to the TCP socket, and then in my test, you know, how to connect to it. It's all loopback, obviously. When it connects to it, you know, and it issues a client hello, then you should respond with the server hello. You know, and it's all still mocked away and segregated. So it's actually not really that different from this. The only real difference is that I don't generally use test case. I use the BDD scenario given when then catch feature, but that's just a matter of taste. It's not a matter of quality. So it's actually not that far off is the short answer. The move.
When you're going to different.
The move for the ownership of the mock rental.
Yeah, I've not particularly come across that before. You're passing those pointers around.
It's
in between all of the different functions.
it's invoking a particular constructor. So if we look at issue rental, right, you can see that it takes this object by value, right? It just so happens that this is only move constructible, so you can have a copy constructor overload, and you can have a move constructor overload. And unique pointer only has a move constructor overload from its own type. So if I remove the std, if I get rid of the std move, it just won't compile. It's only, in fact, I'll demonstrate it. No, that's going to create a pointer to the object. That's a raw pointer to a unique pointer. There you go. See? There is no viable conversion from, you know, this blah 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 mock rentable type to a copy that is an irentable, because it's trying to copy it and it's not copyable. Right? No, because that's just a raw pointer to the managed point, to the smart pointer. Smart pointers are just classes, right? They manage raw pointers for you, but they are still a class, just like string is a class. The address of anything, including a smart pointer, I don't know what it is just yet another raw pointer. It's not a unique pointer. So just also, so I could do this, like, to make it compile, I could do this as well. I could do static. How does that look to you? That's what std move actually does, basically. Anyone want to actually decipher that? Could anyone decipher that?
You're casting.
So you understand the cast part, right? Who here knows static cast at least? Yeah? So that's convert. It's saying I have this type, I want to make it something similar but different. Yeah.
You're converting it into your, obviously your type that you do.
So it's already a unique pointer of mock rentable, right?
It's the double
The magic is the double ampersand, exactly. The magic's all in the double ampersand. So you have a single ampersand, everyone knows what that is, right? A single ampersand on a type, a reference, right? Two of them means it's a movable one. So a single ampersand, I'm slightly cheating on my terminology here, because the official terminology would, like anyone who's a language lawyer would get really mad at what I'm saying now, but I'm going to just try and make it simple. So technically speaking, it's casting it to an X value, but to make it simple for you, a single ampersand would be a reference, or strictly speaking an L value reference, but just call it a reference, and two of them means it's a movable reference. It's still a reference, but it's a special category of reference, right? The normal one you can only copy. A single ampersand is like, I can only copy this. Two of them means I can copy it or move it, if you have a constructor overload that will take it. So there's a constructor overload in unique pointer that takes the two, the two ampersands, and it doesn't, and it deletes the one that takes one ampersand. And that's why this works. Move semantics, wonderful. But we can just do that.
So you think it's like double ampersand, is that you're giving a reference, but then
It's a movable reference.
you're taking that one away and replacing it with that.
It's another category, right? So you know how overloading works, right? So I can take an int, I can take a char, right? I can also take a reference. I can take a type like an int ref, but I can also take an int ref. It's a bit pointless with ints because they're not classes, but on a class it's more useful, right? I can have a class constructor that takes my own type, right? And it takes a single ref. That's a copy constructor generally, like a const ref, yeah, to my own type. I can make a copy of my own stuff into a new instance. But then I can take a ref rather than just a single ref, and that's a special category, because now I'm saying that when I call this particular overload, this ref overload, I know that this is a temporary instance, right? Either because it actually is, it just doesn't have a name, or because the programmer who's using my class has done std move, and they're explicitly saying you are free to gut the contents of this thing. So it's a separate category that I can now overload on and apply this special behavior to, and say, okay, now it's movable.
So the result is now not rentable becomes
Empty.
possession of issued rentable.
So it will call the constructor.
You can't use it where you used it previously.
Well, it will call the constructor, the move constructor, obviously, of unique pointer with the object, and that move constructor will basically take the pointer value, set it to its own, and then it will null out this one.
The previous one.
The one that's being passed in, yeah. Yeah. It does a
Yeah, so the issue rental will use what rentable that I said before. Where you
It's actually using a.
functions or previous class that was using it can't use it anymore.
So this will be empty after it returns, yeah.
Yeah. But inside the issue rental, it will then be usable.
Yes, it's a new class instance that's move constructed from the one I'm giving it there. Okay, so.
So that's so for security, it's good for security then basically, rather than having just the single ampersand and having everything alterable by all your functions.
It's not so much security as, in the case of unique pointer, right, the key is in the name, the clue is in the name, unique. Only one instance actually holds it at a time. So you're physically forced to use this move thing, right? You can't copy it, it's not copyable. Ownership moves around. You never have more than one owner. If that answer your question, or?
Well, I mean, I know from a different context, it's just described as taking ownership or passing around ownership of the resource.
Mm-hmm.
Maybe that's a bit more how we describe it.
Yeah, that's true. That is entirely true. It's taking ownership of the resource, yeah. That's generally why you move semantics are either for restricting ownership to one person at a time, as in this case, or it can also be for efficiency, right? If I move a vector from here to here, it's obviously, if it's got a million elements in it, it's way cheaper than copying it, right? Sorry? Oh, Parvez has a question. Well, it's for the benefit of the video, obviously. There's no silly questions.
So mock rentable is a unique pointer itself, right?
Mock rentable is indeed a unique pointer. If we scroll up a bit. Oh, don't do that. There you go. Yeah. So line 30.
And
It
issue
is.
rental is taking a unique. Yes.
Say again.
Issue rental is taking a unique pointer.
Issue rental takes a unique pointer by value, so we have to call std move, of course.
Ah, by value. Okay.
Yeah.
Yeah, that's.
I could have made it take it by ref, obviously.
Could you have made it take it by ref? Can you do that with a unique pointer?
By ref. Yeah, I could make it take it by ref, but that's a bad semantic to have. So I get what you're
So-
saying, right?
So it's
This
technically
would-
possible, but it's a bad thing
This, no, so you're saying that could be a ref, right? You see that on that
to do.
line?
Yeah.
Yeah. And then down here, we don't even need this anymore, right? We can just do that. But that's horrible.
For some
Actually,
reason.
wait, that's not even compiling. Cannot bind to a value of unrelated type. You're lying to me. That's nonsense. Oh, it's because it's not const. It won't actually work.
What's not const?
No, because the types won't match now because it's not a because it's a reference. It won't make a cut. It can't construct an instance, right? When it's a ref, because this is the interface, yeah. It needs to be by value because it's the interface, so it won't compile. But pretend it's the same type for a second, right? Just pretend that they were mock rentable up here. Obviously, that would make no sense, but just pretend. It's a bad design because if I look at this function's declaration, oh, it takes a ref, right? It's just using it for something. Might change it. But I have no clue that it's going to move it. When it returns, this will do exactly what it did before. It's going to gut the object, but now it's not explicit. Now, I can just give it an L value, give it my variable, and I don't even know this is going to happen. It suddenly hides this horrible class of behavior, right? Gutting my object. So you could, forgetting the type issue, you could use this, but it's bad because it creates a foot gun. It's a massive foot gun, which is that no one's going to know that this thing's going to move without looking inside the code. At least if I take it by value, or if I take it by ref, then it's safe. So by using it this way, there's no foot gun, right? I cannot call the function. Don't do that. I cannot call the function. It cannot compile unless I use std move, which is safe because now when I look here, I know on this line after it returns, I will not be able to use this object anymore. Right? It's explicit. I've moved it into I've done a move. The rule is if you do this, you don't expect this to be usable afterwards.
And,
When you move, you don't expect it to be usable afterwards.
And mock rentable is inheriting from irentable, right?
Mock rentable inherits from irentable, yes. And let me get rid of that.
So, okay. Yeah. All right. Thank you.
Make sense? Is that it for questions? All right, I think that
We got 6 minutes left.
we're basically off time. My throat's killing me anyway. So back to the slides, and as usual, hope you found that informative. Thank you very much, everyone.
Again, thank you very much to Ollie for the class. And as usual, we are going now to pub. So do join us, buy these guys a couple of beers, enjoy talking to each other. Next week, I'm trying to arrange a class, hopefully next door. But I need to speak to this guy. But if you know any space that could accommodate us, do let me know. Yes, I need your help. I need your input. Without you, it's very difficult. So do come to me. And thank you very much for Binary District and Primal Base for hosting us today. Thanks very much.